There is a machine still running on a shop floor in Rochester, New York that was built before the moon landing. It is loud enough that the men working around it wear ear protection. It runs on cams and levers, not code. There is not a line of software anywhere inside it. And roughly every second and a half, it drops a finished brass fitting into a steel catch bin, and then it does it again and again, for months without stopping. The company that built that machine outlived Brown and Sharpe. It outlived National Acme. It outlived New Britain Gridley. What Davenport almost did not outlive was itself. On the 16th of December 2002, the company filed for Chapter 11 bankruptcy protection with $47 million in liabilities against $4.7 million in assets. Welcome back to Trade Archive. If this is the kind of story you want more of, like the video and hit subscribe. It helps more than you would think. The story starts on a hillside farm in Vermont, about 140 years before that bankruptcy filing. Vermont, 1861. A boy named William Davenport is born onto a hill farm in a state where the growing season is short, the soil is thin, and the only reliable export is people leaving. He does not stay. By his teens, he is working in a button factory in Rutland, which sounds unglamorous until you understand what a button factory actually was in the 19th century. Buttons were turned parts, small, round, repetitive, and made by the thousand. To make them profitably, you needed machinery that could hold a size without a man watching it every second. From Rutland, he moves north to St. Johnsbury, to the Fairbanks Scale Company. Fairbanks built platform scales, and a scale is a machine that lives or dies on precision. A scale that reads heavy is worthless. A scale that reads light is fraud. Davenport worked there as a scalemaker, which meant he spent his young adulthood learning that 1/1000th of an inch is a real distance and that machines can be built to respect it. Then a year in Georgia with Rome Scale Works, and then the job that made him, Providence, Rhode Island. Brown and Sharpe. If you did not grow up in this trade, that name means nothing. If you did, it means everything. Brown and Sharpe was the cathedral of American precision manufacturing. It was where the micrometer became a commercial product, where grinding machines became accurate enough to replace hand fitting, where the entire American system of interchangeable parts stopped being a military experiment at the Springfield Armory and became the way the country actually built things. Working at Brown and Sharpe in the 1890s was the equivalent of working at the best aerospace shop in the world today. Davenport spent 12 years there, and during those 12 years, he designed the Brown and Sharpe automatic screw machine. Sit with that for a second, because it reframes the entire story. The man who founded Davenport was not an outsider tinkering in a barn. He was the designer of the single most important small parts machine in America, working for the most respected machine tool builder in America. And then, he left. By 1894, by the company's own account, William Davenport was in business for himself in New Bedford, Massachusetts. New Bedford was a whaling city in decline that was reinventing itself around textiles and precision work, and New England at that moment had an enormous appetite for one very specific product: clock parts. Clock and watch making in Connecticut and Massachusetts consumed staggering quantities of tiny turned components: pinions, arbors, gears, pins, each one small enough to lose in a coat pocket, each one required to be accurate, and each one required by the 100,000. Making them on manual lathes meant a skilled man standing at a machine feeding stock by hand and changing tools by hand all day, for parts worth a fraction of a cent each. Davenport built pinion turning machines to solve exactly that. Interestingly, he did not have his own factory to build them in at first. He had the machines built for him at Morse Twist Drill and Machine Company, also in New Bedford. He was, at that stage, a designer with customers and no plant. He was also, by every account that survives, terrible with money. The line that follows him through the trade press for the next century is that old Mr. Davenport could make anything but money. That is not a modern historian being clever. That is what people in the industry said about him while he was alive. He was a designer of extraordinary mechanical imagination who could not or would not run a balance sheet. His shops moved. He went to Springfield, Massachusetts for a period. The business was never large and never stable, but he was working on something. By 1910, William Davenport had built the first machine that was uniquely his, not a Brown and Sharpe derivative, a 5-spindle automatic screw machine. Here is what that actually means, because the whole rest of this story rests on it. A conventional lathe has one spindle. One piece of bar stock spins in it, and tools come in one at a time, in sequence, to turn the outside, drill the center, cut the thread, and part the finished piece off. Every operation waits for the one before it. The machine is only ever doing one thing. Davenport's machine has 5 spindles, mounted in a drum that rotates on a horizontal axis. 5 bars of steel or brass, each 10 or 12 feet long, feed in through the back of the machine and into those 5 spindles. All 5 spin at once. All 5 are being cut at once, each at a different station, each by a different tool, and at most stations by 2 opposing tools working simultaneously. When the cycle completes, the drum indexes. It rotates exactly 72 degrees, 1/5 of a turn, and every spindle advances to the next station. The bar that was being rough-turned is now being drilled. The one that was being drilled is now being threaded. And at the last station, a finished part is cut free and drops out. 5 operations happening at the same time means a completed part with every index. Not every 5 cycles. On the right job, that is a finished component, leaving the machine roughly every 1 to 2 seconds, hour after hour, from a machine with no electronics in it whatsoever. There is one more piece of the design that machinists tend to single out, and it happens at the last station. On most automatic lathes, when the cut-off tool severs the finished part, it simply falls into a bin, and it falls with a burr on the back face where the tool broke through. Somebody then has to pick that part up later and run it through a second machine to clean it up, which on a job of 500,000 pieces is its own small industry. The Davenport does not do that. At the final station, an independent pickoff spindle comes forward and grips the part before the cut-off tool finishes its cut. The part is never loose. And once the pickoff has it, a back working slide advances from behind and puts a tool into the rear face of the part while it is still spinning. It can deburr it, drill it, chamfer it, or tap a thread into it. The part that drops into the bin is finished. Both ends. That single feature is the difference between a shop quoting 1 operation and a shop quoting 3, and it is a large part of why the machine has been impossible to dislodge on high-volume work. The company also built a variant called the chucker, which strips out the bar feed entirely and instead takes pre-formed blanks or cold-headed slugs for shops that wanted the 5-spindle speed applied purely to secondary work. Davenport understood that he had not so much invented this machine as grown it. He said as much, and the line has been repeated inside the company ever since. The development of a machine, he said, is a growth process. His first machine had about 350 parts. Improvement and simplification added the other 1,500. A machine grows out of a crude infancy, like a boy into manhood. In 1919, the company moved to Rochester, New York, and that decision is the reason there is still a Davenport to talk about. Rochester in 1919 was one of the most concentrated pools of precision manufacturing talent on Earth. Eastman Kodak was there, building cameras and film handling mechanisms that demanded optical grade tolerances. Bausch and Lomb was there, grinding lenses. Gleason Works was there, building the gear cutting machines that the automobile industry could not function without. A city like that produces something you cannot order from a catalog, which is tool makers. Men who can read a print, scrape away flat, and fit a bearing by feel. It was also, geographically, a hinge. To the west was Detroit, where the automobile was about to consume every small turned part the country could produce. To the east was the New England instrument and watch trade that had been Davenport's original customer. Rochester sat between them on the Erie Canal corridor, with rail in every direction. The company settled eventually on Ames Street, on the west side of the city. It is still there. What Davenport did not have still was anyone who could run a business. In 1925, a young mechanic named Earl W. Brinkman started work at the Rochester plant. He would stay for 54 years. Understanding Earl Brinkman requires understanding what kind of skill the Davenport demanded, because he was the best in the world at it, and it made him a figure of something close to legend inside the trade. A Model B is not programmed. It is built, physically, for each individual job. Every motion in the machine, the advance of each tool slide, the feed of the bar, the opening and closing of each collet, the timing of the threading attachment, is governed by cams. A cam is a steel disc or lobe with a profile ground into its edge, riding on a shaft, pushing a follower. The shape of that edge is the instruction. The rate at which the profile rises is the feed rate. The dwell is how long the tool sits in the cut. The drop is the retract. To run a new part, a setup man selected cams from the shelves, and a busy screw machine shop had walls of them, hundreds of steel discs racked and numbered. He calculated the feed change gears to set cycle time. He ground the form tools to the profile of the part. He set the stops, timed the burring spindle, adjusted the pickoff, and then ran the machine and measured what came off and adjusted and ran it again. That process could take a skilled man a full shift or more, sometimes a full day. And this is the trade-off that has kept this machine alive for over a century. Setup is slow and it is expensive and it requires a rare person. But once it is right, the machine will run that part for weeks or months, dropping a piece every second or two, with an operator doing little more than loading bar stock and checking size. A room full of them is an experience. Relays clacking, cams knocking over, cutting oil misted into the air thick enough to taste, brass chips coming off in a continuous curl, and the whole floor vibrating at a frequency you feel in your teeth. Shops fit sound enclosures over them now. Some of the old hands refuse, because a Davenport tells you what is wrong with it before your gauges do, and you cannot hear a chattering tool through a cabinet. Running them was its own identity in the trade. You were not a machinist. You were a Davenport man. The precision is not incidental either. A properly maintained Davenport holds tolerances that surprise people who assume cam machines are crude. On the standard Model B, the capacity is bar stock up to about 3/4 of an inch round on typical machines, with a long bed version extending the part length to around 4.5 inches. The machines weigh about 3,600 pounds. Spindle speeds run from around 500 to 4,500 revolutions per minute, and it will hold size on production parts all day. Earl Brinkman did not just master the setup. He started redesigning the machine around problems that could not otherwise be solved. The most famous of these came out of a socket set screw job. A socket set screw has a hex socket broached into it, and the customer needed the flats oriented in a specific relationship to the rest of the part. On a machine where the spindles simply index and stop wherever they stop, that is not possible. The part is in a random rotational position every time. The story, as it has been told inside the company ever since, is that Earl went home with the problem, told his wife Hilda that he had to work something out, and that she should feed him and leave him alone, and then sat by himself in the house. About half an hour later, he came out grinning and said he had it. What he had was the rev and lock, a mechanism that indexes the spindle to a known orientation and locks it there so a tool can hit the same spot on every single part. It has probably produced billions of set screws since. It is still sold as an attachment today. He also developed bent shank tapping, which took the machine's burring spindle and used it to tap threads into the back of a part inside the machine, rather than sending the part out to a secondary operation on another machine entirely. He sold that method to Albert Champion's spark plug operation, which is the kind of customer that changes a company's trajectory. Those are the ones with stories attached. The paper trail exists too. Earl Brinkman holds patents assigned to Davenport for a bearing assembly for a screw machine spindle, for a chuck closing mechanism for an automatic screw machine, and, my personal favorite, for a method of producing sparking wheels. Sparking wheels are the little serrated steel wheels in a flint cigarette lighter. He worked out how to make them on a multiple spindle machine. That is the range of this business, and it is worth pausing on. The same machine that made the striker wheel in a lighter also made the fitting in a hydraulic line, the hinge in a pair of eyeglasses, the valve seat in a brass faucet, the tip of a screwdriver bit, and components inside spark plugs and shock absorbers. Almost none of it is visible. All of it is everywhere. William Simeon Davenport died in 1937. He was 76. He had designed the automatic screw machine for the most prestigious machine tool builder in America, walked away from it, invented a fundamentally better architecture on his own, and moved his company across 3 states to put it where it could be built properly. He also spent most of his working life close to broke. By the time he died, the man who would actually make his machine profitable had been on the payroll for 12 years. Then came the war. Every artillery fuse, every aircraft fastener, every fitting in every hydraulic line in every bomber required exactly the kind of part a Davenport produces by the 100,000. The Rochester plant ran around the clock. Multiple spindle production was classified as work. The war effort could not proceed without, and Davenport machines were prioritized accordingly. It is also during this period that the machine picked up the designation it has carried ever since. Earl Brinkman upgraded the design in the 1940s, and the result is the machine the industry has called the Model B for 80 years. The war also expanded what Earl Brinkman was, because a machine that complex is useless to a customer who cannot run it. So he went on the road, constantly. He traveled by New York Central Rail to customers across the Midwest, and to reach the plants on the far side of Lake Michigan, he took the overnight railroad car ferry, the SS City of Milwaukee, sleeping aboard while the ship crossed in the dark. On one of those trips, he took the ferry out of Milwaukee overnight and came home. His wife Mary met him with the afternoon paper. The city of Milwaukee had gone down on the return crossing. All hands lost. He was also, apparently, an extraordinary shot. The company tells a story about him taking 3 deer with 3 shots, and about a rifle he acquired at a firearms manufacturer that was a Davenport customer. When the plant ran a batch of test rifles, Earl shot the best pattern of anyone there and was given the gun. He reportedly used it to hit woodchucks at distances that other men did not believe. But the story that says the most about him involves a train and a stranger. He fell into conversation with another man in the machining business during a wartime trip. That man mentioned he had a young mechanic at his shop, a farm boy named Paul Carlson, who seemed to have a feel for the machines. Earl Brinkman came out to that shop on a Sunday, on his own time, and spent hours coaching Carlson personally. Paul Carlson ran that shop for the next 30 years. Earl Brinkman was made president of Davenport Machine in 1966, by which point the name of the man and the name of the company had merged so completely in the industry that people simply called him Mr. Davenport. He inherited a very strange kind of problem. Demand for the Model B was so far beyond what the plant could build that the delivery backlog had stretched to 8 years. A shop that wanted a new Davenport ordered it and waited most of a decade. That is the sort of number an executive can mistake for good news. Brinkman understood it as an existential threat because a customer who cannot get a machine buys a competitor's machine, and Acme Gridley and New Britain were very much still in business. So he went shopping. He bought the best production equipment he could find from anywhere in the world and rebuilt Davenport's own manufacturing capability around it. The backlog collapsed from years to months. By the end of his tenure, the Ames Street plant employed close to 400 people and shipped roughly 50 machines a month, 3 shifts, 6 days a week. His personal motto, repeated often enough that people still quote it, was "Stay ahead of 'em." In 1975, the Davenport Machine Tool Company was sold to Dover Corporation. Dover was a large diversified conglomerate with a specific and openly stated acquisition strategy, which was to buy the best and most profitable companies available in their fields and let them run. Davenport qualified. It was the global leader in multiple spindle machine sales, and it made money. Earl Brinkman stayed on and ran it for 4 more years. In 1979, after 54 years, he retired. And that is the moment the story turns, because Dover never replaced him with anyone who understood what they had bought. That assessment does not come from a critic. It comes from Bob Brinkman, Earl's son, who spent the following decades in the same industry watching it happen. In his account, Dover never hired a manager who really understood the screw machine business. What followed was roughly 25 years of a company being operated by people who could read its financial statements and not its blueprints. The decline. Agonizing. Quality drifted. Parts that were held to close tolerances on paper still had to be hand-fitted in assembly, which is precisely the failure mode of a factory that has stopped understanding why its own tolerances exist. Service degraded. Lead times on spare parts stretched, and the market noticed. Thomas & Betts, the electrical products manufacturer, ran 110 Davenport machines at its plant in Elmira, New York, and had been a customer for more than 30 years. It began buying its parts elsewhere. When a customer with 110 of your machines starts sourcing from someone else, you know something's wrong. There was also an attempt to modernize, and it went badly. Dover-era Davenport tried to reinvent the product as a camless CNC machine and failed. In Dover's own later language, the business continued to suffer from a weak market and from difficulty developing new machine tool products. One detail captures the whole era. When the company changed hands in 2000, the new owner told the Rochester Business Journal that Davenport had not introduced a new product since 1927, and that it had nonetheless, incredibly, maintained an excellent reputation and solid sales. 73 years without a new product, and the brand still carried the business. That is how good the original design was. It is also how much goodwill there was to burn. The burning took less than 3 years. In early 2000, Dover sold Davenport to a consortium headed by a Texas entrepreneur named Donald Lummis, forming a new entity called Davenport Industries LLC. Lummis had run a Dallas kitchen equipment company for 2 decades and had worked at Mobil, Dresser Rand, and Sargent Industries. He moved to Rochester to run it personally. The acquisitions together were valued at around $55 million, with $5 million going to a machine tool builder named Crudgington, and up to $50 million, including future contingency payments, going to Dover. Bundled in alongside Davenport were Crudgington Machine Tool of Fort Worth, Light Machine of Manchester, New Hampshire, and a screw machine service business with operations in Warwick, Rhode Island, and in England. Roughly 100 additional workers joined Davenport's 150 in Rochester. Lummis projected $35 million in revenue that year, rising toward $43 million within 2. The strategy rested on a single bet. John Crudgington had designed an 8-spindle CNC lathe, and the plan was to push it out through Davenport's distribution and customer base. It did not work. The CNC machine never became the business. Meanwhile, the actual business, which was building Model Bs and supplying parts and cams and attachments to thousands of machines already in the field, was being starved. Parts prices went up. Service did not improve. And into that gap walked the secondary market. By Bob Brinkman's count, half a dozen outside producers started making Davenport spares. Once a shop has bought a knockoff cam or a knockoff collet, and it works well enough, that customer relationship is gone. On the 16th of December, 2002, Davenport Industries, LLC filed for Chapter 11 bankruptcy protection. $47 million in liabilities, $4.7 million in assets. 108 years of continuous American manufacturing, insolvent by a factor of 10 to 1. The buyer who emerged was not a private equity fund. Bob Brinkman had grown up in this business the way other children grow up in farming. He started at C.J. Winter, a thread rolling company connected to his father's work, part-time while still in high school, full-time in 1969. He bought the company outright in 1970. Over the following 3 decades, he built it into the leading name in thread rolling attachments and dies, added Gates Albert in 1990, a screw machine company his father had once owned, and added another precision shop in 2000. In 2003, with his chief executive Andy Laniak, he bid on the assets of the company his father had spent 54 years building and won. Then he walked into it. His own description of what he found is unsentimental. The plant was filthy. The machine tools were in disrepair. The customer base had eroded to a fraction of what it had once been. Employment was down to about 20 people. In 1979, when his father walked out for the last time, there had been close to 400. He described the job the way you would describe eating an elephant, one bite at a time. The rebuild was methodical, and it was mostly unglamorous. The CNC project was killed. Engineers from Rochester Institute of Technology were brought in to re-engineer the machine's tolerances from proper datum points, so that parts fit in assembly instead of being fitted by hand. Unnecessary operations were removed. Feeds and speeds were modernized. A real quality system went in, and the division was certified to ISO 9001 in 2004. Prices on spare parts were cut by roughly a quarter to fight the knockoff producers on their own ground, backed by the argument that a genuine part from the people who designed the machine is worth having. And the customers came back. Thomas & Betts, the company with 110 machines in Elmira that had walked away, came back. Its purchasing agent, Jeffrey Blank, told the Rochester Business Journal in 2005 that Davenport did everything they could to earn our business and then some. By then, he was buying nearly 100% of his parts from them. Then came the part nobody expected from a cam machine company. Davenport started replacing the cams. The first step had actually come in 1996 with the Servo B, which used servo motors to take over functions that had been mechanical. Under Brinkman, the work went much further. A new high-precision head, patented under the name of engineer Sandro Belpano, redesigned the spindle assembly entirely, with a one-piece outer spindle, 3 front and 2 rear angular contact bearings, a labyrinth seal, and an air and oil lubricant mixture. It took the machine's accuracy from around 0.003 of an inch to 5/10,000ths. Then the servo work went after the linkages themselves. Patents issued to Davenport describe an automatic screw machine with multi-axis drive control, replacing mechanical shafts, clutches, and cam trains with programmable servo drives running under PLC control. Those patents note, almost in passing, that the machine they are modifying was originally built in the early 1900s and produces parts at rates from 120 to 4,500 pieces per hour. The current version is called the hybrid. It keeps the 5-spindle drum, the 72-degree index, and the mechanical speed that no single spindle machine can match. And it adds CNC axes and G-code. A shop can change the geometry of a part on a screen instead of grinding a new steel cam. That matters for one reason above all others, and it has nothing to do with technology. It is demographic. The generation of men who could set up a cam machine by feel is retiring and not being replaced. The hybrid exists because the machine outlived the trade that ran it. Today, Davenport Machine still builds machines on Ames Street in Rochester as a division of Brinkman International Group, alongside C.J. Winter, Gates Albert, and the defense and precision operations. The company puts the number of Davenport machines deployed worldwide at over 14,000. Buell Automatics runs more than 50 of them. Gent Machine runs around 40. MS&J Screw Products runs 25. Bob Brinkman has since retired as chairman. Every American machine tool builder that competed with it is gone. But the dinosaur is still on the floor in Rochester, still indexing 72 degrees, still dropping a finished part into the bin every second and a half.